Welcome guys to this special help session before Major 1, Term 231. So the content, we're going to go through the solution of Major 1 2 years ago. Okay, so this is the first question. Question 1. The statement that is wrong about this following parametric curve. What do we have? We have x equals sine hyperbolic of t, and y equals -1 plus cosine hyperbolic of t. T is the parameter which goes from -infinity till +infinity. So here are the choices: A, B, C, D, E. Of course, here in the master version, you always have A as the correct answer. Let's just try to decrypt or understand how we solve these kind of questions. First of all, we all know that, what do we know? We know that cosine hyperbolic squared minus sine hyperbolic squared equals 1. That's a general rule we know for the cosine and sine hyperbolic. You might have seen that in 102 or 101, depending which calculus book you've taken, but right now they're taking it with 102. So if we start from this hyperbolic equality, so what do we have? We have then cosine hyperbolic is y plus 1. So instead of cosine hyperbolic squared, we will have y plus 1 squared. Minus sine hyperbolic squared becomes minus x squared. And here we go, we have what we have, a rectangular relation. Okay, and this is clearly of the form like x minus a squared minus y minus b squared, which equals something. And here, this is kind of hyperbola. Okay, now what we need to figure out here is the kind of general relations we have for hyperbolas. Hyperbolas are the cousins, kind of the ellipsoids, for the ellipses, and we know that for ellipses, what do we have? We have x, let's start by C special ellipses, which are squared, like x minus a squared plus y minus b squared equals like r squared. And circles, we've seen it many times, are very special ellipses. And what we can tell about ellipses is just we're gonna have x minus a squared over some parameter, let's say c squared, plus y minus b squared over some d squared equals 1. And here we have just the negative sign, so it's an hyperbola. Any question on that, guys? All the other possibilities are wrong, because clearly this won't pass through the origin. It passes through the origin when we have what? If you plug in 0, 0, what do we have? We have 1 squared equals 1. Yeah, it goes through the origin, so that's correct. The curve is symmetric about the y-axis. That's correct. The Cartesian equation can be written x squared minus y squared plus dy. That's correct. And we have for t less than 0, the curve lies in the second quadrant. Yeah, in the second quadrant. So what is wrong is that the curve is an hyperbola. You know, hyperbolas, they look like this. If you follow the mouse, you have something like this. You will have a vertical asymptote kind of, or slant asymptote, and a vertical asymptote, or a horizontal asymptote and a vertical asymptote. So that's about the first question. Any question on this, guys? I have something in the messages. No. Okay. Any question, guys? Shall we move on? Okay, next question, question 2. We have the surface area of the solid obtained by rotating the parametric curve, which is, well, which section is this? I think it's 10.3, if I'm not wrong. Huh? We have the parametric curve given by x of t equals t cubed minus t, and y equals t cubed minus t. Okay, and if you rotate it about the x-axis, which kind of formulas do we have to use? Of course, if you rotate about the y-axis, the radius is going to be y. So we'll use the integration from a to b, 2 pi times the radius times the square root of dx over dt squared plus dy over dt squared, what you see here in the second line. Okay, so if you plug in y of t, which is t cubed minus t, and if we perform the derivatives, of course, the derivative of t cubed minus t is 3t squared minus 1. Same thing here, 3t squared minus 1. And if you expand what is inside the square root, what will they have? We'll have kind of 94 minus 6 t squared plus 1. So basically, you see that this term, which is squared, is repeated twice. So if you put it as 2 times 3t squared minus 1 squared, immediately you can put the square root of 2 outside. And that's why we have square root of 2 outside. Okay. So at the end of the day, you have just to integrate a polynomial of t. And this is what you should get. So this is for the second one. Okay. So we always have to be careful about the miscalculation. Everything that is that would make us lose our points just because of silly mistakes. Any question on this, guys? These are easy questions. As we said many times, the first, as we said many times, the first couple of questions are quite easy to solve. So we shouldn't lose much points there. Okay. Now, if you move to question 3. Here we start talking about polar curves, and this is with the current textbook is section 10.4. And the old textbook, I think it was 10.3. So what do we have here? We'd like to find the number of intersection points between these two polar curves. We have the first one, which is r equals 1 over 3. We have that look into the solution. Of course, when r is a constant, we know it's a circle. This is what we will have. Now, the first curve is r equals sine 2 theta, and here we'll have a 4 leaved rows. Okay, so you can imagine that you have the 4 leaved rows, and of course we expect to have how many? 2 times 4 intersection points. Okay, you can even get them exactly if you wish, but I think it's very trivial question. It's kind of a gift if you, of course, provided that you know the shape of these kind of curves, and they leaved rows. They leave roses and how they look. Any question on this, guys? Nothing? Like, okay. If you do you have any special question? شباب ما شاء الله. Very good shape. طيب. Question 4. Yeah, what do we have? The graph, which is r squared equals sine 2 theta. R squared equals sine 2 theta. Is symmetric about what? Now, let's check the other possibilities. This is the graph. Of course, many times we said like you have to be in control of what these kind of graphs look like. Huh? So here what they're saying is that since r squared is positive, for sure, so what can we say here? The sine of 2 theta needs to be positive, right? And we know that the sine of 2 theta is positive if the angle here 2 theta is between 0 and pi. So for sure we need, if 2 theta is between 0 and pi, then theta is between 0 and pi over 2. Okay. So you'll have to imagine that theta goes only from 0 to pi over 2 because sine of theta is equal to r squared. Okay. So if you go from 0 to pi over 4, you'll go this way. So you reach this point at pi over 4 because you'll have what? You have sine of 2 times pi over 4, which is pi over 2. Sine of pi over 2 is 1. So r squared is 1. There are two possibilities here. Either you are here So r is 1, or r is equal to -1. So it will be the other on the other side, like symmetrically with respect to the origin. And you see, understand now from where we get answer A, it's symmetric with respect to the origin only. Okay, so when you go, in fact, from 0 to pi over 4, you will draw simultaneously this arc and this arc, because of the fact that r squared is equal to something. So we'll have the plus and minus solutions. Is that okay, guys? Anytime you can interrupt me, you can ask a question, of course. Now, so these four questions were easy, as you understand. Now let's go to the business. So here the question is about the area of the region that lies inside, question 5, the area of the region that lies inside the cardioid, given by r equals 1 minus sine theta. This is the cardioid you see here, 1 minus theta. And outside of the circle, which is given by r equals 1. Where is the circle r equals 1? This one. That's the r equals 1, and the cardioid is here. Okay, so they're saying that it is inside the cardioid and outside of the circle. So we're talking about this dashed part. Okay, so what we need to find here to make sure that we are getting the right bounds for integration. Of course, now about the shape of the integral, we have an outer region and an inner region. So we're going to have kind of r squared, r1 squared minus r2 squared. All we need to figure out are the points of intersection. Okay, and if we try to make the first curve intersect with the second curve, what do we get? We get 1 minus sine theta equals 1, which means sine theta needs to be to 0. And sine theta would be equal to 0 where? Exactly. Sine theta would be equal to 0 at 0, pi, 2 pi. Okay. So now here the answer is that the integral should be what? Should be from pi to 2 pi, because of course we need to make sure that we have a positive area, and that's why we're going to have from pi to pi to 2 pi. Now when let's check it out. When we are at 0, sine theta equals 0, where are we? 0, we are at 1, so we are here. We start from here. Okay, so we already have a point of intersection. Okay, so what do we want? In fact, we want to make sure that we're going from pi to 2 pi, because when we are at pi, we are here. We are at 1 pi. Okay, so we try to cover the whole distance, the whole region which is below here, which is between the circle and the cardioid. So in fact, we integrate from pi to 2 pi. r1 squared minus r2 squared. So we'll have 1 minus sine theta squared minus 1 squared. So you end up with what? With r1 minus sine theta squared is 1 minus 2 sine theta plus sine theta squared. 1 minus 1, so we are left with minus 2 sine theta plus sine squared, and sine squared, here we replace it by, we substitute it by 1 minus cosine 2 theta over 2. So we get a beautiful integral, and we can get out of it. Okay, so you have to take care of the miscalculations, guys. Any question on this? Let me check. Someone wrote something. Any question, guys? Ziad, Turkey, Faisal.
Doctor, could you upload the file
on the blackboard?
Yeah.
Yes, hold on a second. Yes, be my guest. Or section 15 or 17? Faisal.
17.
Okay, I'll do it. Just 1 second. Done. Type. Anything else? Okay, so any question on this, guys? Type. Should I proceed? Let's go to question number 6. What do we have? We'd like to have the area of the region enclosed by the inner loop. Okay, that's more interesting. Of r equals 1 minus square root of sine theta. Okay, now what do we need to find out? We need to find the right period. Okay, so what do we have here? When we go from at 0, what do we have? We have 1 minus square root of 2 times sine of 0. So at 0, we are at r equals 1. So we are here. Okay, 1, 0. Okay, what happens when theta increases? The sine increases. So 1 minus square root of sine gets shorter, decreases till you reach what? Till you reach pi over 4. Why pi over 4? Because at pi over 4, you have sine of pi over 4 is square root of 2 over 2. So you have square root of 2 times square root of 2 over 2 is 2. Divided by 2 is 1. So 1 minus 1 is 0. At pi over 4, you are at the pole. Okay? Type, what happens next? So here in this table, we move it from initial point 0, 1. At pi over 4, we are at 0. What happens at pi over 2? At pi over 2, you're going to have 1 minus square root of 2. So instead of being on this side of the line theta equals pi over 2, you'll be here, 1 minus square root of 2. What happens? You went like this because r became negative. In fact, the angles were here above pi over 4, but because of the sign of the radius, you are drawing this arc, the one on the left here. So that's from pi over 4 to pi over 2. Okay, so if you are drawing this from pi over 4 over 2 and you want the area of this region, all you need to get the total area is to double it. So that's exactly what we are doing here. You multiply by 2 this area, half of the integral from pi over 4 to pi over 2 of what? Of r squared, 1 minus square root of 2 sine theta, and you multiply it by 2 to get the area. So that's the whole idea. So remember, there are basic fundamentals to figure out how the curve or the polar curve looks like. Take a couple of points, significant points, which tells you from where you start, when do you reach the pole, when you have intersection, and then you will be able to figure out how to draw the to curve completely and to find the bounds of the integral. Any question on this, guys? تمام؟ كل شيء تمام؟ Okay. So next one, that's question 7. Okay, that's no longer in part of the major one. So here you see we're talking about plane. Okay, because the question is about the intersection of a sphere with radius 7 with the xy plane. Okay, we can solve it, but I don't think we are. We can solve it. There's no issue. Let's go. So we have the intersection of the sphere with center minus 1, 4, 2. We can get the equation of the sphere. Radius 7, so that's the r squared, 49. Intersection with the xy plane. What does it mean, xy plane? Means z equals 0. So you just write z equals 0 here, you get this. Of course, the intersection of a plane with a sphere is going to be a circle, so you're going to have this circle, x plus 1 squared plus y minus 4 squared. Here we have 4. You bring it to the right side, you have 45 now, which means that the square root of 45 is your radius. So that's why you have a circle which is centered at -1, 4, and with the radius 3 square root of 5. Okay, it's easy. There is no doubt about it. Question? Any question, guys? Right. The vector that is question 8 that has opposite direction. What does it mean opposite? It goes on the opposite direction of our main vector, which is here 4 minus 3, 0, but has length 10. Okay, length 10, which means, first of all, I should get a unit vector from vector v here, or u. They're calling it u here. So from u, I get a unit vector when I divide by the magnitude of u. I multiply that by 10 to have a length of 10, and by -1 to make it opposite. And that's it. So it's going to be 4 minus 3, 0. What is the magnitude here? Square root of 16 plus 9. So square root of 25, which is 5, which means I'm going to have 10 over 5 minus 2 times 4 minus 3, 0. It's going to be, for sure, minus 860. Okay, guys? Any question on this? So remember, if they ask you to have a vector with a given length, try to obtain, first of all, a unit vector from your vector, and then multiply by this length. Question 9. The vector v with length square root of 8 that lies in the first quadrant and makes an angle pi over 4 with the positive x-axis. It's easy. Okay, you can easily draw it. That's the angle pi over 4, kind of a polar sketch. Length square root of 8. So you need the magnitude of square root of 8. How can one construct this? To have an angle pi over 4, you can recall that the dot product of v, if v, because we are on 2D here, yes, if you assume v has component AB, so v dot I is what? Is magnitude of v times magnitude of I times cosine pi over 4. So it's square root of 8, that's for magnitude of v, 1. And here, cosine of pi over 4 is also square root of 2 over 2, or 1 over square root of 2. Square root of 8, don't forget, is 2 square root of 2. So you can cancel the square root of 2, and you are left just with 2. What does it mean? The first component, a, here, because of the dot product, when you multiply v by I, you have a plus 0. A times 1 plus b times 0. So the first component, a, is 2. The second component, of course, you need the dot product with j. And here we're going to have also 2. And you can double check that the magnitude here is going to be square root of 4 plus 4, so square root of 8. Okay? Any question on this, guys? Any question? Okay. Type. If the angle between now question 10. Any question on 9, guys? If the angle between the vectors u and v is pi over 3. Okay. Now, this question is a little bit delicate. Please stay focused. If the angle between the vectors, because we need some properties here, huh? If the angles between u and v is pi over 3, and we know that the magnitude of u is equal to 3 and magnitude of v is 2, then what is the magnitude of u plus v? Okay, this is a kind of recurrent theme we explore. We explore the knowledge of the student on the given properties here. So the magnitude of u plus v here, which is what we're looking for, how can one express it in terms of magnitude of u and v? So the trick is that the magnitude of u plus v, by definition, is the dot product of the vector by himself. So if it's u plus v dot u plus v. And from now on, we're going to use the properties of the dot product. Properties we explored during the lecture. We have distributivity here. So it's going to be u dot u. So immediately u dot u, we know that's magnitude of u squared. We know this. Then we have u dot v. And we know how much is u dot v. So we're going to have 2 times u dot v because of the other item we're going to have. 2 times u dot v, that's basically 2 times magnitude of u, magnitude of v, cosine of pi over 3, y cosine over 3, because this is the formula of the dot product. Okay? Now, the last component is v dot v, which gives me magnitude of v squared. And we know that magnitude of v is 2. So basically, we're going to have magnitude of u squared is 9, plus 2 times 3 times 2 times half. We have some cancellations. We're going to have 9 plus 6 plus 4, 19. Which means that magnitude of u plus v squared is 19. The magnitude of u plus v is square root of 19. Okay? So there's a beginning. Don't forget, the magnitude of a vector squared is the dot product of the vector by himself. Question, guys? Right. Now, which section is that? I think it's section 11.3, okay, in the current textbook. So we have u in question 11, which is 1, negative 1, 2, v3, negative 2, 0. We want 2 times u, that's easy, minus the projection of u onto v, that's something I know. So we need to prepare this vector first. All dot v. So let's prepare this vector. Okay. Now there are 2 ways to do it. If you go by brute force, okay, or you can save some time if you know some properties. Okay. Here they know some properties. So they said, look, whatever happens, u minus projection of u into v. So we have u, the projection of u into v is going to be this long vector you see here. Okay. So u minus projection of u into v is this following vector, this w. See it? That's something we've seen in class. For sure, this vector is orthogonal to v. So what is left? Yani, instead of writing 2u minus projection of u to v, you can split it. The 2u becomes u plus u minus projection of u into v, all dot v. The second part, when you multiply this vector w here by v, is going to be 0. So basically, the whole question asked just for the dot product u dot v. Okay? Of course, if you didn't know this trick or you didn't recall what is u minus projection of u into v, okay, this is what we called in the lecture the orthogonal component of u in terms of v onto v. Okay, so we have to understand that this is orthogonal to v. So basically, it ends up by doing just the dot product u by v. Okay. So if you take 2 steps back, you understand that we are talking about concepts that are being tested. Do you have a full understanding of some of the concepts? Question? Any question, guys? Right. Question 12. We have, okay, I think that looks like something similar, right? Here, the question is formulated different ways. It looks like this question we had during in the quiz 2 last week. Here we have these points, 210, 21 minus 1, B 3032, C4 minus 2 minus 1, D 3M0. We would like to find the value of M that makes all 4 points coplanar. And our question, we had M and N. Huh? Right. So all we need to do is to get the component of the 3 vectors, perform the triple product. So if you perform the triple product, you get something in terms of M here. You get -2, you get 2 plus 6M. 2 plus 6M that needs to be equal to 0. It's -1/3. Okay? And if you recall, I told you that we almost the same question appeared like 10 years before. Exam 111, if you recall. But in that case, with the same set of points, we asked for the volume of the parallelepiped. Am I right? Okay. Type. Now, question 13. The question is about the set of all points at which the parametric curve. Okay, so we're going back now to the first part of the semester. The set of all points at which the parametric curve x equals t cubed minus 3t and y equals t squared minus 3t when t goes from -infinity to +infinity has a vertical tangent. Well, basically, what do we need here? We need to find dy over dx. Okay, it's dy over dt divided by dx over dt. First of all, dy over dt is 2t, dx over dt 3t squared minus 3. Tamam. So if you're looking for vertical tangent, what do we need? We need the denominator to be equal to 0, while the numerator is not 0. The denominator, which is dx over dt, equal to 0 when t squared equals 1, which means t equals plus or minus 1. And you can double check that the t equals plus or minus 1 doesn't give a 0 in the numerator in dy over dt. Okay, so we have now the full setting of t, either it's 1 or -1. At 1, you're going to have 1 minus 3, 1 minus 3. So it's -2, -2. And at -1, we're going to have -1 plus 3. So it's going to be 2. And the y is going to be 1 minus 3. It's going to be -2. That's why we have 2 minus 2. Okay. Of course, don't forget to check that the zeros of the denominator do not provide the 0 in the numerator. If they do, there is a way to go around it, but it's not explored in the current textbook. We go around it by using the L'Hopital rule because we have a form 0 for 0, and we go back to 101 stuff. It's not explored in this textbook. Any question, guys?
So if we have 0 over 0, we should not consider that as a vertical.
You cannot conclude unless you go use the L'Hopital rule. Okay, because you have a limit when t approaches something of a form 0 over 0, right?
Yes.
Yeah, you got it. So for example, let's say you have in dy of the t was 2t minus 2. Let's assume you have -2 here, huh? So 1 is a problem because you are going to have a 0 up and 0 down, right?
Yes.
So what would you do? A form 0 over 0, you need to explore the limit when t goes to 1 of 2t minus 2 over 3t squared minus 3, right? So the limit is going to be now derivative of 2t minus 2 is 2. You already removed the 0, right? Well, downstairs, you're going to have 3 times the derivative of t squared, which is 2t. So 6t. So the limit is going to be 2 over 6.
6t.
Yeah, 6t, t is 1. So 2 over 6 is 1 over 3. So the limit is a constant. You don't have a vertical tangent. Just in case you had 2t minus 2, for example. Maya?
Yes.
Okay. This particular issue is not explored in the current textbook. In the previous textbook, it was correctly explored using the L'Hopital rule. Here, I went through the section back and forth. They don't talk about it, but it has been visited also the same question in last year's major, 221. There is a similar question, but using sine and cosine. Like,
so
question
we will have.
Yeah, go ahead.
So we will have 1 over 60, right?
Mm-hmm.
And then substitute 1. So we'll get 1 over 6.
You mean but the particular equation when you have 2t minus 2?
Yes.
The derivative of 2t minus 2 with respect to t is 2, right?
Yes.
And the derivative of 3t squared with respect to t is 60.
Yeah.
So you're going to have 2 over 6t. Now you place t equals 1, you're going to have 2 over 6, 1 over 3.
Uh-huh.
It's not an undefined determined form. Yani it's not plus infinity. So you don't have a vertical tangent in that case.
Okay.
Even though
Okay.
you had a 0 downstairs and a 0 upstairs in the form dy over dx, when you use the L'Hopital rule, this has been removed. You got it?
Yeah, okay. Yeah.
في واحد بيسأل على الهلب سيشن، بعطيه اللينك. احنا بس خليني ارسل له اللينك شباب. طيب ان شاء الله ما يكون راح. طيب any other question guys? فيصل, is it okay?
Yes. Okay.
طيب let's move forward. طيب what else do we have? We have question 14. خلينا 13 14. The set of all values of b that makes هون في that make مو makes the angle between the vectors 2 1 minus 1 and 1 b 0 equal to pi over 4. Hello. How do we get the angle between two vectors? We need a dot product, right? So if you do the dot product of these two vectors here, 2 1 minus 1 and 1 b 0, you're going to have magnitude of u, magnitude of b cosine theta. So basically what you need is cosine theta equals 1 over square root of 2. So you have an equation which tells you that from the side, component-wise, the dot product gives you 2 times 1 plus b minus 0. Component-wise, you do the sum of the product of the components. And magnitude-wise, you get magnitude of u, which is square root of 4 plus 1 plus 1, so square root of 6. Magnitude of v, square root of 1 plus b squared. Here on the other side, you have cosine theta. So basically, you have this equation, 2 plus b equals square root of c, square root of 1 by b squared. Here we squared both sides. So you have 2 plus b squared. On the other side, we have 6 plus 1 plus b squared over 2, which is equivalent to say when you say 6 over 2 is 3. So 3 times 1 plus b squared. You end up with the following equation. If you develop this, you have 4 plus 4b plus b squared equals 3 plus 3b squared. So you have this beautiful equation that writes as, in terms of b squared, you're going to have 2b squared minus 4b minus 1 equals 0. Here you just apply the discriminant rule. Here it's going to be plus or minus, it's going to be minus 4, so plus 4 plus or minus square root of minus 4 squared minus 4 times 2 times minus 1. So you're going to have 4 plus or minus square root of 24 over 4. This is 24, yes. You can simplify by 2 if you wish. So it's this. So that's why you have these two answers. 2 plus square root of 6 over 2, 2 minus square root of 6. Here, I don't like the numbers, but it's not my opinion that counts. Okay, I would have tried to make here the roots of the equation more trivial, but it's okay. I think it's something that you can solve. Any question on this, guys? So don't forget here when you talk to then when the angle is given and you have one parameter inside and you want to find the correct value for it, go directly for the dot product, huh? And you have two alternate formulas for the dot product. Question, guys? كل شيء تمام؟ Okay, let's move on. Type question 15. Okay, that's basically the last page, by the way. Yeah? So we have the distance from the origin to the line passing through the point 0, 1, 3, 1 minus 1, 2. That's section now, right now is section 11.5. It's not part of the major one. It's something we already explored this week, but it's not part of the material for this major. The distance from the origin to a line. Okay. Right. And that's the last question we have in this major. I'm going to share with you another major, which is the major of last year. Any question, guys, before we move forward? Right. Not many questions. That's not exactly expected. But خير إن شاء الله. Right. Here, I'm going to share with you the second major, the major of last year. You guys see it right now? Do you have it, or do I need to upload it on the Blackboard, guys?
Upload it, please.
Please, okay. Just 1 second. Okay, it's uploaded for section 17 right now. I don't know, anyone from section 15 here? No? طيب. Okay, let's go. Waiting for others to join. كيف هذا؟ لا لحظة. Let me just invite someone. Okay. Okay. Hopefully you see the exam, guys. طيب, let's start. بسم الله الرحمن الرحيم. A particle moves 3 times counterclockwise along the circle given by x squared plus y minus 1 squared equals 9. Hello. If the particle starts at the point 3, 1, is it part of the circle? Yes, because when you plug in 3 squared, you get 9 plus 1 minus 1 squared, so 9 equals 9, it's part of the circle. Then the parametric equations of the path of the particle are. So they were looking for what? From conversion from rectangular to parametric equations. Okay, so the idea here, what is the idea? Now, for those who understood very well this section, it's very trivial, because you will see that here, if I know that x is anyways r cosine theta or r cosine t, okay, here, because I'm kind of centered at the origin with respect to x. And what do we have? For the y, you see I had to remove 9 minus 1 to get the equality sine squared plus phi squared equals 1. So if you plug in here x squared, you have 9 cosine squared plus y minus 1, so it gets 9 sine squared equals 9. Makes sense. Okay. I think here it's very easy. You can just proceed by elimination. Now, why they're saying 3 times for the period here? T goes from 0 to 6 pi, because when you go from 0 to 2 pi, you move through along the circle just one time. Got it, guys? Right. Now, question 2, the curve given parametrically by the following: x equals tan theta, y equals 2 secant theta. When theta is between minus pi over 2, pi over 2. Of course, we have to exclude the minus pi over 2, pi over 2 because of the tan function. The tan is not defined at these 2 points. Okay, what is it? Is it a hyperbola? What do we know here? We know that tan squared is equal to what? It's 1 plus, sorry, secant squared is 1 plus tan squared, صح? Secant squared in general of theta is 1 plus tan squared. So if you write it, which means that secant squared is tan squared minus 1. Okay, here we don't have exactly secant squared, but if I want secant squared, I'm going to have y over 2 all squared. So basically, x squared is y squared over 4 minus 1. And that's a hyperbola. Okay, تمام. Now, question 3, the curve given the following by the following parametric equations. What is it? Now, the question here is about not sketching, not areas. We would like to find the horizontal and vertical tangent line. Right. You see all the possibilities here are talking about horizontal and tangent vertical and vertical tangent lines. So we need to compute the x over the theta. For sure, it's easy because we're going to have minus 6 cosine of theta squared sine theta. Now, for dy over dt, I differentiate sine, is going to be plus. So it's going to be 3 times 2, 6 sine squared cosine theta. Okay? Now, dy over dx, if you divide these two, the 6 goes 6 over 6. So you're left with minus 1. And you have, what do we have? You have a sine, cosine. Sine, cosine goes. So upstairs, you're going to have a sine, just sine left. Downstairs, a cosine. So you end up with minus tan theta. Minus tan theta equals 0 when theta, يعني when the sine is equal to 0. It happens what? At 0 or at pi, for sure. Okay? So now we can see that we already have how many possibilities for theta. Now they're saying here that theta is between 0 and 7 pi over 4. Hello? Now, if we look at d parity, we have dy over dx equals 0 when theta equals 0. When theta equals pi. Now, do we have two different horizontal tangent lines there or not? First of all, when theta equals 0, I have x equals 2 cosine of 0, which is 0. Okay? 2 cosine of 0, sorry. So 2 cosine of 0 is this, which is 2. Am I right? The cosine of 0 is 1. 2. And y equals 2 sine of 0, which is 0. So I'm at the point 2, 0. Now, when theta equals pi, I'm going to have x equals 2 cosine of pi cube. Cosine of pi here is minus 1. Cube, I'm going to have minus 2. Okay? And the y is 0. But what happens? You have theta equals pi, and the x is minus 2. Okay? So what is the minus sign? Whatever happens, you have the same horizontal tangent, which is a slope of 0, which is y equals just 0, basically. So you have one horizontal tangent. Now, what about the vertical tangent lines? of course, since dy of dx is 0 here, sorry, is tan theta, is minus tan theta, this tangent line is vertical only on this period at pi over 2. Because you'll have only to remove from 0 to 7 pi over 4, you only have to remove how much? Pi over 2 or minus pi over 2, 3 pi over 2. Yeah, but whatever happens, you're going to have one single horizontal line, because whether you get theta pi over 2 or pi or minus pi over 2, you're going to have just one vertical tangent line. Okay, there is more explanation here. They're finding the points here, and more explanation about why do we have one horizontal line, as we explained just right now, because you have just, in fact, the two lines are superposed, y equal to 0. For the one tangent line, it's the x equals 0, and it's also superposed. Question 4. The concave, now, the curve given by the parametric equations, t cubed minus 3t and y equals t squared, concave up. Yeah, about the study of concavity, so we need to find dy over dx, first of all. It's going to be dy over dt, which is 2t, divided by dx over dt, which is 3 times t squared minus 1. Yes, because you're going to have 3t squared minus 3. Here. Now, what they did here, first of all, they looked for points where possibly they have a horizontal tangent and a vertical tangent. It doesn't matter. We look for the second order derivatives. So, you know, we understand, we recall the formula, d squared y over dx squared, derivative with respect to t of dy over dx. So we differentiate this guy again with respect to d, we have a quotient rule. We end up with the following, minus 2 times t squared plus 1 over 9 times t squared minus 1. Now we have to study the sign of this. Now hold on again. T squared plus 1 is always positive, whatever happens. So minus 2 wins, negative sign here. And to be able to conclude on the sign of the whole second order derivative, we need to know the sign of t squared minus 1. If it's positive, so the whole sign is negative because of the negative 2. So the curve is concave down. If it is negative, it's going to be concave up. Now, between minus 1 and 1, the term t squared minus 1 is negative. So if you make it to the power cube, it remains negative. So you get negative or negative with positive. So you have a curve which is concave up. Okay. Now, concave down when t is less 0. It's not true. That's obvious. I know, because between minus 1 and 0, you will have it concave up, whatever happens. Concave up when t is larger than 0. Not true, because when t is larger than 1, it's going to be concave down. Concave down between minus half of half. It's not true, because we already said that's going to be concave up. And concave up when t is larger than 1, it's not true, because we said when t is larger than 1, we're going to have a negative sign, so it's concave down. Questions? Type. Question 5. We're talking about areas now, which is equivalent to section, I think it's 10.3. The area of the region closed by the curve that is given by the parametric equations x equals 2 cosine, y equals half of sine theta, when theta is between 0 and 2 pi. So which formula did they use? So here, what do we have here? Y equals half of sine, x equals 2 cosine. Why do they integrate from 0 to 2y dx? Let's focus. When theta is equal to 0, okay, the x is where? The x is at 2, because you have 2 cosine 0, which is 2. Okay? And the y is at 0. So you are at 2, 0. If your theta goes from 0 to 2 pi, you will end up at the point 0, because you have 2 cosine of 2 pi is 2. and y is equal to 0. So you come back to the same point. Okay. So what does this represent exactly, Shabab? Anyone? What do you think it represents?
Circle.
Are you sure? If you isolate here, x equals, can I share with you? There is a whiteboard I recall in here. Share whiteboard. Let's share whiteboard here. Microsoft whiteboard.
ellipse, صح? Right?
نعم.
Ellipse.
Who said I ellipse, Faisal?
Yes.
Yeah, it looks like an ellipse. Yes. Why do you see black whiteboard, Shabab? No. There was a problem. I have a problem displaying the whiteboard. I couldn't. Right. So if you let's go back to it. Let's explain why is it an ellipse. You wanna take over, Faisal? Explain why is it an ellipse. I'm gonna
Because
write
when
here.
we
I found it. Yes, go ahead, Faisal.
when we solve for cosine, we will get x over 2.
Yeah.
And solving for sine theta, we will get 2y.
Okay.
And we have the identity cosine theta squared plus sine theta squared equals 1.
تمام.
So x over 2 squared plus 2y squared equal 1.
Yeah.
And when we solve, we will get an ellipse.
Yes. So we're talking about here the area of an ellipse. We're looking for the area of an ellipse. Okay. So if you're looking for the area of the ellipse, yani the ellipse would look, I thought I've seen something here. But I'm limited with the technology offered by the teams here. Not sure it's gonna work. Now needs an upgrade. Right. We're talking about the area of the ellipse. So what we want here, that's why we multiplying by 4, because we have 4 parts in the ellipse. And that's why when we go from, when x goes from 0 to 2, basically, what we have, we have 1/4 of the area and multiplied by 4 to get the total area. Okay. So basically we just integrate from 0 to 2. When x goes from 0 to 2, تخيلوا انتم عندكم الellipse goes like this without drawing on the board. I'm not able. The whiteboard didn't load. You have like an ellipse like this. We're talking about this part. Okay. And x goes from 0 to 2. We integrate just y. And that's it. That's basic math 102 stuff. طيب. Now, so question 6. The surface area of the solid generated by rotating the curve given by the parametric equations x equals 6t, y equals 3t squared when t is between 0 and 1. Very good. That's the question from 10.3, I think. Huh? Here, we use the formula for the surface area, okay, which is inherited from the formula of the arc length. So we're going to have 2 pi, the integral from 0 to 1 of what? Of the radius, the curve given by the parametric equations, rotating by the y-axis. If you rotate by the y-axis, the radius is x, so 60, okay? And what you're gonna integrate is square root of what? Dx over dt squared plus dy over dt squared. This square root gives you square root of 6, because derivative of dx is 6, and here 60. So that's what happened here. That's what they tried to do to give you this part. 6 gets out of the square root, and you have 6 square root of 1 plus t squared. So basically, you end up with a beautiful integration. And you know, this is something you visited already in 102. You have 2t square root of 1 plus t squared. You make u substitution, u equals 1 plus t squared, and you are out of it. Okay? Be careful again with miscalculations. So what is the idea here? Basically, that's a direct application for the formula of the surface area for the parametric equations. 10.3. Question 7. The polar equation given by tan theta secant theta. What does it represent? Okay. Here it's you're gonna play with the expression, and that's what they did. Just a moment, please. Okay, so sine theta over cosine theta, that's tan theta times secant, that's 1 plus cosine. So basically, what do we have here? R is equal to R cosine squared equals sine theta. If we square both sides, what do we have here? If we multiply both sides, sorry, by R. On one side, I have R squared cosine squared. I know this is X squared. On the other side, I have R sine, which is Y. Okay? So basically, I have Y equals X squared, and for sure, this is a parabola. Which kind of parabolas is going to be inclined towards like the right side, okay? And with the x-axis as the axis of symmetry. Any question on this, guys?
It's not a normal parabola, Doctor.
It's not a normal parabola. It's a sleeping parabola with respect to the x-axis. تمام؟ لأنك عندك y equals x square. يعني لو أنت رسمت كده الأكسس is gonna be sleeping like this. يعني it's looking toward the right side. y لازم يكون positive صح؟ لا أنا غلطان. y لازم يكون positive صح؟ so يكون كيف السليم y equals x squared. Yes, it's positive. Yeah. No, it's a normal parabola. Sorry. What am I talking about? My mistake. Too late. Y equals x squared. Normal parabola, Faisal. Sorry. Type next one. Maybe this is gonna be the last one. I'm feeling tired. And many of the guys left already. طيب خلينا نخليها الأخيرة يا شباب unless you have a question, particular question. خلينا نحل هذا السؤال يلا. بسم الله. The graph of the polar curve r equals 3 cosine has a vertical tangent line where? So x equals r cosine. So we're going to have r as 3 cosine. We're going to have 3 cosine squared. The x of the theta is going to be minus 6 cosine sine. تمام. So basically, minus 6 cosine theta, sine theta is equal to 0, needs to be equal to 0. Why? Because we need the denominator to be equal to 0. So it's like saying that sine 2 theta equal to 0. ليش sine 2 theta? Because we have minus 3, like minus 6 cosine theta. Sine theta is like minus 3 sine 2 theta. Sine 2 theta is equal to 0 as 0 or pi over 2. Okay? When theta equal to 0, we're going to have r equals 3 cosine of 0, which is 3. And when theta equals pi over 2, we're going to have r equals 0. So it has a vertical tangent line where at 0, pi over 2, yes, for sure, because the second point is not given, which is 0, 3. 3, 0. 3, 0 is not among the choice. Okay? طيب. I'm going to stop here.
Don't have to check the...
Yes, because the 3, 0 is not given. You see, they tried to mislead you. It's not exactly what I wanted to say, but they didn't give the appropriate angle with the 3. should have been 0. In that case, you would have 2 right choices, which is not the case here. You got it?
Yes.
There are 2 points, 3, 0 and 0 pi over 2. 3, 0 is not given. So 0 pi over 2 is the only one given. تمام شباب? Do you have any particular question? طيب, I think we visited يعني at least superficially, we didn't solve in details most of the patterns or most of the contents we need to cover. Here we're talking here in question 9 about the slope of the tangent line. Okay, so we need to find di over dx. In question 10, area of a region closed by a polar curve, 2 minus cosine. Okay, so we need to figure out what is the shape of the graph here. Unfortunately, here we don't have the graph. You can easily add it to the solution. Now, here, what do we have? The area, it looks like the question we solved it from 211. R equals 1, and R equals 1 minus sine. You have kind of inverted cardioid for R equals 1 minus sine. It's basically almost the same thing. Here, we talk about the arc length, direct application. This is a distance from 2 points to a plane, and here it's not part of the content. Here, we're talking about the unit vectors that are parallel to the tangent line of the curve. That's interesting, because we need to find the tangent line to the curve and to find the corresponding vector. خلينا نركزوا مع هذا شباب. طيب, I have y, which is 2x squared minus x. Hello? If you differentiate, what do we get? We get y equals 4x minus 1. At the point 1, 0, what is the slope? 3. Hello? Okay. So the slope is 3. We would like the unit vectors that are parallel to the tangent line. يعني if you know that the slope of 3, يعني لازم يكون y على x يكون عنده 3 value. And you have a unit vector. So if you like assume u is a over v, is ab, you need b over a to be equal to 3, and the square root of a squared plus b squared to be equal to 1. These are the only choices you're going to have. Okay? لأنه من جهة لازم يكون a equals b over a is equal to 3, يعني b is equal to 3a. So you end up with a squared plus 9a squared and square root equals 1. يعني 10a squared equals 1, which means a squared is 1 over 10. يعني a is plus or minus square root of 10. 1 over square root of 10. Okay, it's not clear. The solution is not clear here, but hopefully you understood. واضحة شباب الفكرة ولا لا؟ You need to start by u. You're looking for vector u with component ab. So from here, you understand with the slope that the b over a is equal to 3. يعني a is equal to b over a is equal to 3. So b is 3a. So when you get the magnitude equals 1, it means that the square root of 10a squared is equal to 1, which means that a is plus or minus 1 over square root of 10. تقريبا هذا هو الشباب. البقية يعني we visited everything. Any question شباب؟ هذا على cross product. Suppose that you have two vectors a and b that satisfy the following. The dot product gives you root of 15. The cross product gives you this. We'd like to find the angle. أول شيء, the dot product gives you one equation, and the cross product in magnitude gives you a second equation. So you have the value of tan theta. Here is going to be square root of 5 or square root of 15. يعني 1 over square root of 3, and we know that theta would be pi over 6, because that's the unique solution from minus pi over 2 to pi over 2. This question 19 is about the area of triangle. يعني لازم تسوي triple product تقسم على 2. Okay. We would like to find the A that makes the area of the triangle equal to root of 6. So when you do the triple product, ايش سوى هو؟ The magnitude, sorry, the magnitude of the cross product. The magnitude of the cross product واقسمها على 2 هو جاب 2 square root of 6 because half of the magnitude needs to be 2 square root of 6 يعني the magnitude needs to be 2 square root of 6. So we have a second degree equation of A. One of the roots is negative. You take the positive one, A equals 2. And here again a question like the one we had in the quiz about coplanarity. You know the idea, we already visited the concept. And here we solve with respect to only one single parameter, which is A. Any questions, شباب؟ طيب جزاكم الله خير. Have a wonderful night. إن شاء الله نشوفكم بكرة. السلام عليكم ورحمة الله وبركاته.